Assalamualaikum and hello everyone. So today we are going to finish our chapter 5 application of integration, and our last subtopic for today is the volume of revolution. At the end of this lesson, you should be able to calculate the volume of revolution using definite integral. So for today, we are going to study about three methods to calculate the volume of revolution. So the first method is this method, and then we have washer method, and lastly we have shell method. So before we are going to study these three methods, let's look at the basic first. So volume is basically the integral of the cross-sectional area at any x of ax. So in other words, if we integrate the cross-sectional area, so we basically get the volume. So the formula will be given as the integral from a up to b, ax dx is equal to vx, which is the volume. So let's look at the method 1, this method. Okay, for this method, let's say we have y is a function of fx, and then there is a region bounded by interval of a up to b. Okay, let's say the function rotating at the x-axis or revolve about y is equal to k. So basically we have a disc shape like this at the A section and also the B section D. And notice that the area of a circle is actually A is equal to pi r square. And then of course we have to find the r, which is r in this case is fx minus k. So here is where we get the formula of the volume of revolutions, such that integral from a up to b pi r square. So r we substitute fx minus k, so we get pi fx minus k square dx, and then we can actually put pi outside, then we get pi integral dx. Okay, so how about revolve about x is equal to k, or we can actually say that it revolves around the y-axis. So it's actually the same, where the area of a circle here is pi r square, and then we get r fy minus k, and then here's the formula, pi integral a up to b fy minus k square dy. So let's look for example 5. So the region below is bounded by the curve y is equal to x plus x square. The line x is equal to 1, and then another line is x is equal to 2 and y is equal to 0. Okay, find the volume of the solid generated when the region is revolved about the x-axis. So we know at this graph, at the example 5, it revolves about x-axis, means that y is equal to 0. So looking back at the formula, so we know that k is equal to 0. And then by using that formula, we get v is equal to pi integral 1 up to 2. Okay, based on the shaded region there. Okay, and then in bracket x plus x square, which is a function, minus with k, we get 0. Okay, and then square dx. We simplify, and then we get x squared plus 2x cubed plus x to the power of 4. Okay, and then we integrate, we get pi in bracket x cubed over 3 plus 2x to the power 4 over 4 plus x to the power 5 over 5 from 1 up to 2. And then substitute 1 and 2, and then we get the final answer is 481 over 30 pi. Okay, let's look at another example. The region below is bounded by the curve y is equal to square root of x plus 2, and the line x is equal to 4 and y is equal to 2. Find the volume of the solid generated when the region is revolved about the line y is equal to 2 using this method. Okay, this is the same. So it revolves about y is equal to 2, so we know that k is equal to 2, and then substitute into the formula of volume of revolution for this method. So we get pi integral of from 0 up to 4 in bracket square root of x plus 2 minus k, which is 2, and then square dx. Simplify, then we get only x, and then we integrate x squared over 2, substitute, and then we get 8 pi. Example 7. The region below is bounded by the curve x is equal to y square and the line y is equal to 2. Find the volume of the solid generated when the region is revolved about the y-axis. So at this graph we know that k is equal to 0 because it revolves about the y-axis, mean that x is equal to 0. So substitute the formula. So we get v is equal to pi integral 0 up to 2. So here we will using a dy, so we get y square minus 0 square dy. Okay, so we get pi integral 0 up to 2y to the power of 4 dy. And then we integrate, we get y to the power of 5 over 5. Substitute and then we get 32 over 5 pi. Example 8. The diagram below is bounded by the curve x is equal to 5 minus y square and the line x is equal to 1 and y is equal to 0. Find the volume of the solid generated when the region is revolved about the line x is equal to 1. Okay, for this case it revolves x is equal to 1, so k is equal to 1. And then substitute using the formula, so we get v is equal to pi integral the shaded region is from 0 up to 2. Okay, we look at the vertical, and then in bracket 5 minus y square minus 1 because k is equal to 1 square dy. Simplify and get pi integral 4 minus y square square dy. And then simplify, integrate and substitute, then we get the last answer is 256 over 15 pi. So let's move to another method named as washer methods. It will become tricky if we get two functions at the same time and then we only need to calculate the volume of the shaded region. So how this method works? So basically if we revolve these two functions that intersect each other, so we actually get two part of this shape, which is one is the outer part and one is the inner part. So here's the formula. So v is equal to pi integral a up to b fx minus k square dx, which is the outer disk. Okay, and then minus with the inner disk because we don't want this part as we need to calculate this part of shaded region. So it minus pi integral a up to b gx minus k square dx. So this is for the case if it revolve about y is equal to k. So how about the washer method revolve about x is equal to k? So the method, the formula method is given as v is equal to pi integral of a up to b fy minus k square, which is the outer part, and then minus with pi integral of a up to b gy minus k square dy, which is the inner part. And then let's look at the example 9. The following region is bounded by the curve y square is equal to x and line y is equal to negative x plus 2. Find the volume of the solid generated when the region is revolved about the y-axis. So since it revolved the y-axis means that x is equal to 0. So k is equal to 0 here. So we need to use a dy, which is in y term. And then we get the outer part of this shape. You should choose the function of 2 minus y, which is okay, pi integral of negative 2 up to 1, 2 minus y minus k is 0, and then square dy, minus with the inner part, which is pi integral of negative 2 up to 1. Okay, the inner part is y square, okay, and then minus k, which is 0, square dy. And then we simplify, then we get like this, and then we integrate this part, and then we substitute all the value, then we will get the final answer as 72 over 5 pi. Okay, example 10. Region R below is bounded by the curve y square is equal to 4x and the line 2y is equal to x plus 3. Find the volume of the solid generated when the region is rotated through a complete revolution about the line y is equal to 2. So we have two function and then it revolve about y is equal to 2. So we get k is actually is equal to 2. And then we have to substitute into formula. Okay, the outer part is actually y square is equal to 4x. Because it revolves about y, so we have to use the x term. So in the x term, okay, and then it's actually square root of 4x minus k. So k is equal to 2. So basically we get pi integral of 1 up to 9 square root of 4x minus 2 square dx. And then we have to minus with the inner part, which is pi integral of 1 up to 9. So the inner part is the straight line, which is to y is equal to x plus 3. And then we have to make into x term. So we get x plus 3 over 2. And then minus 2 close bracket square dx. And then simplify the integrals. And then we integrate. We substitute the formula, then we get the final answer as 32 over 3 pi. Let's move to the last method, method 3, which is named as shell method. The idea concept of this method is that by taking out the cross-sectional area of this cylinder. So if we're taking out this blue part of cylinder, actually we get the surface area of 2 pi RH. And then also, of course, sometimes we have the inner part and the outer part. Okay, and then by integrating this surface area of 2 pi RH, actually we get V is equal to 2 pi integral A up to B Rx Cx dx, where Rx is actually the radius R and Cx is the height or the length of the cross-sectional area. Okay, so let's move to the next example. Okay. The shell method, if revolve about y is equal to k. So by looking at this formula, actually we need to find the Rx. So how we need to set up the Rx? Okay, is by looking at the line x is equal to k, the position where it whether it is the left side or the right side of the function or the shaded region that we need to calculate. If the shaded region is the right side of the line, okay, so means that the Rx we need to set as x minus k. But if the line is the right side of the function, or the function is the left side of the line, so actually we need to set up as Rx is equal to k minus x. So if it's revolve about x is equal to k, so we need to determine by looking at the position whether it is the above or the below the function or the shaded region. So if it's below, so ry is equal to y minus k. If it above, so ry is equal to k minus y. Okay, let's look at example 11. The diagram below shows the region bounded by the curve y is equal to x squared plus 1 and y is equal to x plus 7. By using shell method, find the volume of the solid obtained by revolving the region about the line x is equal to negative 2. So we need to find Rx and we also need to find Cx. Okay, Rx is a radius. So actually to find the radius, we need to look at the position of the line that it is revolved. So x is equal to negative 2. Because the line x is equal to negative 2 is the left side of the shaded region, so we set Rx is equal to x minus negative 2. So we get x plus 2. Okay, Cx is actually the length or the height of the cross-sectional part. So we have to determine the outer part and the inner part, and then we have to find the difference. So we have to determine the Cx by subtracting from the outer part and then subtract by the inner part. So in this case, the outer part is x plus 7 minus the inner part is x squared plus 1. So we get Cx is equal to 6 plus x minus x squared. So now we have Rx and Cx. Then we substitute at the formula, which is 2 pi, and then the region bounded by the curve is from negative 2 up to 3, and then substitute Rx Cx, we get this x plus 2 and then 6 plus x minus x square. We simplify, we substitute, and then we get the final answer as 625 over 6 pi. Example 12. The diagram below shows the region bounded by two curves, x is equal to y square and x is equal to 3 minus 2y square. Find the volume of the solid generated by revolving the region about the line y is equal to 2. So we need to find Rx and Cx. Okay, sorry. At this question, we actually need to find Ry and Cy because it revolves about the line y is equal to 2. Okay, so since the line y is equal to 2 is actually above the shaded region or the region bounded by the two curve. Okay, so actually we need to set up k minus y. So k here is 2, 2 minus y as the ry function. Okay, and then we need to find cy. Cy is the outer part minus inner part. So the outer part here is the right side minus the left side. Okay, the right side is 3 minus 2y square and then minus with y square. And then we get 3 minus 3y square. And then we have to substitute into the formula. So the region bounded from negative 1 up to 1. So we get 2 pi integral negative 1 up to 1. In bracket 2 minus y, in bracket 3 minus 3y square dy. And then we simplify, we substitute, then we get the final answer as 16 pi. That's all for today. Let's check your comprehension.